Hi, thanks for joining this virtual conference. My name is Jan Brugård and I am the manager of the development team of SystemModeler. In this virtual conference, you will learn the basics of SystemModeler. It will be divided into 4 separate sessions. In the first session, I will introduce the basic concepts of the tool. It will give you an idea of how you could be using the product. In the following 3 sessions, my colleague Patrick Eckenberg will take you step by step from learning how to simulate ready-made models to creating your own models using drag and drop, taking you from the level of model consumer to model developer. This part will be more hands-on and you will be able to follow along if you have SystemModeler installed on your computer and repeat what Patrick is doing. During all of the sessions, you will be able to ask questions through the chat, and Patrick and I will be replying them directly in the chat or orally in between sessions, depending on the question. The world of system modeling is huge, and modeling can mean many different things. You might use pen and paper to draw a model of something, use some CAD tool, or even a 3D printer. Or you might be developing mathematical models of different kinds. The method will depend on the type of system you are studying and the task in hand. So let us look at what SystemModeler focuses on. SystemModeler is developed to study the dynamics of systems or even systems of systems. The system can be something relatively simple, such as a pendulum, or something more advanced, such as an aircraft or a propulsion. If we start by looking at the aircraft example, we might want to study its flight dynamics. Or in the case of life science, we might want to look at the population and see how sickle cell disease is spreading through a population. We distinguish between 2 different types of usage. As a model developer, you develop models either for your own use or for someone else to consume. As an example, you might be teaching population dynamics and would like your students to be able to explore how different traits affect a population. Then you can develop a virtual lab consisting of a model of user interface that allows the students to explore the traits. Here we can see how we are step by step through drag and drop building up a model for studying of sickle cell anemia. So we are setting a name for the new component, giving it a description, and once we're happy with the description, we apply that, and we might want to set some connect it to the rest of the system, of course, and once connected, we'll set parameters as we would like. As a user, I could then receive something like this notebook, where the developer has given instructions on how to use it, and I can fill in different things like the probability that sickle cell child will be born, and that will affect the results in some virtual lab that we have set up. And here we can see we have sliders to change different properties in the model, and we can look at what happens if we are in a malaria endemic population or not. So creating virtual labs is one reason for using system models, but of course there are more. If we take virtual labs a bit further, we have training simulators, which try to replicate the behavior of some real-world system. Another key area is model-based design, where you can use models for explore design space, virtual test systems, design controllers, and many other things, of course. So what type of requirements does this set for a modeling tool? Well, from the example of usage in the previous slides, it is obvious that just being able to model and simulate is not enough. You need to be able to do things like analyzing your system, develop user interfaces for virtual labs, calibrate parameters, and so on. Furthermore, you would like the model to naturally mirror the system actual model. This makes it easier to build, maintain, and share. This means that you often need to mix multiple kinds of domains. For instance, an electric kettle model might need a combination of electrical and thermal models. Along the same line, you need to be able to combine continuous and discrete behavior, just as real-life system would. SystemModeler is built from the ground up to meet these demands. So let us look at them one by one, beginning with the last one. Let's get back in time a bit and look at the good old-fashioned trebuchet. The actual throwing and flight of the stone is best modeled as a continuous system, while the logic for how the catapult is governed might be better modeled as a discrete process. Furthermore, you would probably like to model the bouncing as discrete events. In SystemModeler, you can easily combine these two as shown by the animation of a very bouncy stone. I mentioned an electric kettle as an example of a system that requires components from different domains. So let's explore this a bit further. As you can see in the model diagram, we have pointed out 4 different types of components. We have a resistor or thermistor that is used to heat up the water. So this resistor is basically the coil in our kettle, and then we have the water here. We have a temperature sensor that takes us from thermal over to numerics, and that then numerics is used connected here to a logic block where we go from numerics to a logical decision, and this logical operation or signal is fed back to our opening switch, where the logic is used to control an electrical component. So we see this kind of loop of things interconnecting different domains. So even if this is a very small system, it required a bunch of different domains to be able to model it correctly. As you saw in the previous example, the components in SystemModeler are generally easy recognizable. This is a key aspect if you want to model a large system, such as this model of the flaps in a Cessna Conquest 441. In this case, the model developer has developed his own components for the top-level model, one component for the pilot, one for the electrical system, one for the flaps, for the landing gear, motor, hydraulic system, and so on. And you can easily recognize them in the top-level view. You can also dig in to the component by clicking on it. So for instance, if we open the electrical circuit, we can see that it's built up by bulbs, wires, sensors, and so on. And in the same manner, if we click into the flaps, we see that the flaps consist of an hydraulic system and a mechanical system that interact. And on top level, all these systems interact with each other, of course. So this capability of having something look and being organized as a real-life system is crucial if you want to be able to develop something large and communicate that with others. Finally, and probably the most important aspect, once you have invested the time in developing a model, you would probably like to get as much mileage as possible from it. While developing a model and simulating with different parameters might be very valuable in itself, the ability of creating virtual labs, optimizing your system, performing sensitivity analysis, and so on is key to get that mileage. That is exactly what the combination of SystemModeler and Mathematica gives you. So in this seminar, we're focusing on the drag and drop and connect part that enables all this and the kind of one-click simulations. But beware that there's more to it in SystemModeler and the Wolfram language. It allows you a full simulation control and an unlimited set of analysis and design tools. If you want to combine your system model with machine learning, you can do that. If you want to do control design, you can do that. If you want to document it, you can do that, and so on. So almost whatever you would like to do is up to you how you want to combine it and how you want to analyze it. And then, of course, you can share in several different ways, including through the Wolfram language. So that concludes my part of this conference. And I will soon hand over to Patrick Eckenberg, who will take you through how you can start using SystemModeler by exploring ready-made models, how you can use these models to modify them and adjust them according to your needs. And finally, in the last session of the day, how you develop your own models with drag and drop. All these sessions are a bit more hands-on. You will see the actual tool in use, and it will go in a pace so you can follow along if you have an installation on your computer. And as I said before, you're welcome to ask any questions through the chat, and we'll try to assist with answers. Thank you very much.